Hey everyone in Algebra 2 land, it's Mr. Lineski here with your top 5 and under 5. Very quickly, these videos are just the top 5 things that you should know for the test in order to be successful. Here's a quick rundown of what we will be discussing in this video. So let's get started with number 1. Number 1, we talked about the number system. We kind of give you a number and you need to place it in all possible number systems that it could possibly fit in. As a reminder, it is sort of a catch-all. I had described these as a stack of pancakes. Imagine that you're sort of sticking a skewer through the pancakes, and that whatever system it goes through all of those pancakes. For example, if I had picked the number, let's say -4. -4 is an integer, so that would go through integer, rational, real, and complex, so it would fit all of those particular situations. So make sure you look over and know those number systems. Number 2 is the powers of I, so don't forget the trick there. If we give you something crazy like I to the power of 40 here, how do we figure out what that is? We had the trick of dividing by 4. We had two ways of looking at it. We had a pattern where it was I1, I1. Remembering that the negatives are in the middle here, so you can use that pattern to help you out. Or if you like the divide by 4, so you would take 40 divided by 4. That gives you 10, which is a whole number, which would simplify to just 1. So you can use the 0.25, the 0.5, the 0.75, or the whole number kind of method if you like that as well. Number 3 was rationalizing the denominator. This one was kind of tricky, so I have some examples here. For rationalizing the denominator, you're basically multiplying by the conjugate. Remember, if it is a pure imaginary term, the conjugate here can just be -I. So you would multiply both the numerator and denominator by -I, giving you -2i divided by -3i squared. As a reminder, I squared we know is equal to -1, so that gets replaced with a -1, and we are left with this. Something a bit more complex like this one over here, we would make sure that we multiply by the conjugate, and then we distribute. So here we get 2 minus 6i divided by 1. Remember, the middle terms cancel out, so this ends up being -9i squared. Replace that I squared with a -1. We get 2 minus 6i divided by, this becomes 1 plus 9, which is 10. So that would be our answer. Actually, just kidding, we would need to simplify this by dividing each of those by 2. Factor out a 2, gives us 1 minus 3i divided by 5. Sorry about that. So that would be your answer. Number 4, solving an absolute value problem. So just remember that when you see those absolute value bars, you're going to have to set up two equations. Before you do that, though, you have to make sure the absolute value is isolated. Just as a reminder, if it's an inequality, that we have the gray Tor problems, that those are going to result in OR graphs, and that typically means the graphs are or when we shade, it's going to go in opposite directions. And then the AND graphs are when we shade sort of in between two numbers, like a sandwich. So here we would subtract 7 from both sides first. You get 2x minus 3. 20 divide by 2, we get x minus 3, absolute value greater than 10. And now this is where we set up both sides of our equation. So this is a greater than problem, so we're going to have the OR. So that's going to give us x minus 3 greater than 10, x minus 3 less than -10. So remember, when we set up the two equations, we have to flip the sign, and we also have to change the sign on the number. So when we solve this, we get x is greater than 13, and we get x is less than -7. So when I graph that on my number line, open circle at -7, shading this way, open circle at 13, shading that way. And finally, number 5, we are looking at how to graph an absolute value problem. So remember, we have the equation y equals a, absolute value x minus h plus k. First thing you want to always check for is if there's a number in front of the x. If it's somewhere in this area here, we need to factor that number out first, and then we can set up the problem. So we have the vertex is always at the point hk. Sometimes visually it might look like h is the opposite because there's a negative here in the equation. But k you always leave the same. Your axis of symmetry is that folding line. That's going to be at the equation x equals h. A always represents the slope of the line, which is the rise over the run. Don't forget that if it's an inequality that we are graphing, that we have to shade those graphs. If it's a less than or greater than symbol, we're going to have a dashed line. Less than or equal to or greater than or equal to, we're going to have a solid line. If it is less than or equal to, we're going to shade below the graph, and if it's greater than or equal to, we will shade above the graph. Alrighty, that is it. Thank you for watching. I know it, and now you know it.